I am going to go over some of the bookwork questions that I've been getting in 3.1 because it is due tomorrow at the end of the day. Okay, so you have until 11:59 on Friday to get all of your bookwork. There was bookwork, but then there was also that worksheet. All of that needs to be turned in on PowerSchool Learning by tomorrow. So I'm going to go through actually a lot of evens since those aren't in the back of the book. So starting with 32. These can be kind of tricky. So one question I had was actually just asking a good question. They asked if you needed to write an equation of this line to be able to do these. And that is a good question. If you had an equation of the line, this would actually be really a lot easier, right? But that's actually not the idea here. The idea is that you just use the graph to be able to answer these without the equation. You could write an equation because you can write an equation of a line as long as you have 2 points on the line. You have 3, but we're going to do this solely with the graph. Okay, so part A, when is g of x equal to 20? That's the y value. Actually, all of these are y values. And then all of the answers I'm going to put over here are x values. So they ask the question using y values, and you give the answer using x values. So when is g of x, when is y equal to 20? When x is equal to 5. Okay, B, when is g of x equal to 60? It's the y value. Well, that's when x is equal to negative 15. Part C, when is g of x equal to 0? When is the y value 0? When are you not up or down at all? That's when x is positive 15. That's the intercept. Okay, and then D. Now we start these inequalities. When is g of x? And then you need to be able to read this correctly. You need to know how that reads. Solve for when g of x is greater than 20. Another way to say that is when is the y value above 20? Okay, so here is the y value 20. And then above 20 is all of these y values. All of those, that portion of the line has y values greater than 20. Well, describing that using x, okay, this is where it gets tricky. If I'm going to describe that portion of the line using x, that's when x is, weird. Oh, I picked the calligraphy pen. Interesting. Okay, that's when x is less than 5. E. Okay, when is g of x? I'm going to erase this now. When is g of x greater than 20? No, I just did that one. Solve for when g of x is less than or equal to 60. When is the y value less than or equal to 60? Well, so here is the y value 60. Here are all the y values that are less than 60. So when it comes to writing my answer, I want the x values that are greater than negative 15. But since it included the y value 60, I get to include the x value negative 15. Okay, and then F. When is g of x greater than 0 but less than 60? AKA, it's between, those y values are between 0 and 60. Okay, so in between the y value 0, okay, that's right here, and the y value 60. So that's just that portion right there. So since we're not going to include any of the y values, so we're not including any of the x values, that is when x, it is greater than the x value negative 15. So you go in order from smallest to largest always when you write a compound inequality, but less than the x value 15. Okay. Next one. This one just has 2 parts. Part A, but it has 3 lines. When is F equal to G? Okay, so you need to locate F is the one that has a slant, a negative slope, and G is the bottom line. Okay, so when is F equal to G? Well, that's when they intersect. So part A is, again, you're not writing the coordinate. It's giving Y values. Your answer is an X value when X is equal to 7. Okay, then this one gets interesting. When is G of X less than F of X less than or equal to H of X? Okay, so another way to say that, let's start with this first part, G of X. This means when in the graph is G the lowest portion, the lowest thing on the graph. Okay, so like right here, is there anything below it? No. Over here, anything below it? No. Okay, then if I look over here, is there anything below this portion right here? Yeah, because this line is extending this way. Okay, so that's when F actually becomes the lowest. But if I look to the left of X equals 7, G is the lowest. Okay, next question. When is H the highest? When is H the highest on the graph? Okay, that is this line right here. So right here, it is actually the highest. Yes, there's nothing above H right here. And over here, it's also, it's not the highest because F is going to be above it. So right here, here's H, but F is above it. So when does it go F between G and H is another way to think about that. So when is F sandwiched between G and H? Well, here's F, and right here for this interval, and then between those intersections, it goes G on the bottom, and then F in the middle, and then H is the highest. Okay? So when it comes to writing this answer, this is when this gets a little tricky because one of them is included and one of them is not. So I'm going to start by writing my answer like this. Okay, so remember your answer is X values, and the X values are -4 and 7. Now, okay, this is very important. Are you listening? Most common mistake is they say, well, it goes not equal to, so therefore it must be this one that I'm including. And it could be, it's very possible, but that's not the thought process. It's not, oh, since it's the second one here, it's also the second one here. That's not how you figure that out. The way you figure this out, and again, that could be the answer. I honestly don't remember. But I just want you to realize just because it's the first one that's not included and the second one that is, that doesn't mean that that's the way it is here. How you determine that is we are going to include when F and H intersect. Okay, so locate F and H. So F and H intersect at F and H intersect at -4. So it's the -4 that we are including. Okay, so it actually does, I like this example, it ends up being different than the order here. Non-included, included, included, non-included. Okay, so rewind that, listen to it again if you didn't understand that piece. It's one of the benefits of online learning. You can pause and rewind if I'm going too fast. Okay, so 38, I've had a few questions on this one. I think that you're okay with part A. You can plug in 50 and give me the cost. If your cost is $29.32, you can set C of X equal to $29.32 and solve for X. What I have been having questions on is, oh, and I guess part C, suppose that you budget yourself $60 per month for the phone. What is the maximum number of minutes you can talk? Well, if 0.38 X plus 5 represents the amount you spend, you're only allowing yourself to spend 60, so you need this cost to be less than or equal to 60. That's what you would set up for part C. Okay, for part D, what is the implied domain? Okay, so you can graph this. If you were to graph this up 5 and then you have this slope, okay, so like so. Okay, so the implied domain, starts off with the fact that you can't have negative minutes. There's no such thing as negative minutes. So x must be greater than or equal to 0. But is that it? I mean, is there any other factors? Well, the other factor is that there's only so many minutes in a 30-day month. Okay, so you can't talk for an unlimited amount of minutes because you don't have an unlimited amount of minutes in a month. Okay, so they're securing that by saying that there are 30 days in that month. So if there are 30 days in that month times, so let's imagine you talk for every single minute of every single day for 30 days. Okay, not realistic, but it's going to be your domain. So 30, sorry, that's 30. 30 times there are 24 hours in each of those days, and in each of those hours there are 60 minutes. So 30 times 24 times 60 is, I'm going to include it because technically it's possible, but I don't think anybody has ever done it. Talked for that long on the phone. Okay, 43,200 minutes. That's the implied domain for the context of this problem. So I don't know. Obviously, this is not drawn to scale, but there would be some portion that you would also cross off in this graph. Okay, last what I want to do, I wanted to for sure try to keep this under 15 minutes. So it's 46. Suppose that a company has just purchased a new machine for its manufacturing facility for $120,000. We've talked about this straight line depreciation method. So that means that write a linear model, so the value of the car, well, it would be this it starts off at $120,000. So this is actually the y-intercept. But then it starts losing money as time goes on. So as time goes on, I'm going to subtract the slope. And the straight line method means you take the value of the car and you divide it by the amount of years you're depreciating it for. So that ends up being 12,000. Okay. So you'd clean that up and write that nicely for part A. So then part B, what is the implied domain of the function found in part A? Okay, again, let's draw a sketch of this. So if it starts at 120,000, that's the y-intercept. This time we have a negative slope. So it's actually going to cross the x-axis somewhere. Where is it going to cross? Because that's our domain. X must be greater than 0, and it must be less than whatever this number is, because whatever this number is, after that point, we end up at a negative value for a car. Okay, so how do we find the x-intercept? Well, we set y equal to 0. $12,000. Okay, so if you add that over, divide by 12,000, you get that x is equal to 10. So it loses its value in 10 years. So this is 10, 0. So that means that anything, technically again, this is a line, so it technically goes on over here. But a lot of the times in real world, we only exist in quadrant 1. So the domain would be x such that x is between 0 and 10. And then I think we've actually done part C. We have graphed this. This is years, Might want to add labels. You do want to add labels, euros, years, and but this is the value of the car. It's the y-axis. Okay, so I've just done some evens for you. You need to get the rest of the homework done by Friday at 11:59 p.m. And then on Monday, you'll have all day to take a short little quiz over just 3.1. Email me with questions.